Hibernate. Hibernate is a high-performance, open-source, object-relational persistent and query service. Hibernate takes care of the mapping from Java classes to database tables and from Java data types to SQL data types. It provides data query and retrieval facilities that significantly reduce development time. Hibernate's design goal is to relieve the developer from 95% of common data persistent-related programming tasks by eliminating the need for manual, handcrafted data processing using SQL and JDBC. Hibernate eliminates repetitive and tedious coding work and enables developers to focus on the business problem. Hibernate provides a buffer between the two data representations and enables a more elegant use of object orientation on the Java side, all while keeping the relational schema normalized and guaranteeing data integrity. With Hibernate, you will have short-lived single-threaded objects containing persistent state and business function. You'll be working with persistent objects, and any change made to the object will be reflected on the database tables. Persistence simply means that we would like our application's data to outlive the application's process. In Java terms, we would like the state of some of our objects to live beyond the scope of the JVM so that the same state is available later. The picture on the left represents a high-level view of the Hibernate architecture. As you can see, you have the application at the top level, then all the persistent objects, Hibernate configuration files, and at the end, the database. The picture at the right side is the comprehensive architecture. This will abstract the application away from the underlying JDBC JTA APIs and allows Hibernate to manage the details. Hibernate defines and supports the following object states: transient, persistent, and detached. Let's take a look at the state diagram of such states. As you can see on the picture, when a new object is created, it's in transient state. If the save or save or update method is called, then the object passes to the persistent state. After this, if the session is closed, then the object is detached. Also, the object could be manipulated again calling the save or update, or merge methods, and in this case, the object will be again on a persistent state. If the session's method delete is called, the object is removed and garbage collected. Here you have a summary of the object's transition states. Transient state. An object is transient if it has just been instantiated using the new operator and it is not associated with a Hibernate session. It has no persistent representation in the database and no identifier value has been assigned. Transient instances will be destroyed by the garbage collector if the application does not hold a reference anymore. Use the Hibernate session to make an object persistent. Persistent state. A persistent instance has a representation in the database and an identifier value. It might just have been saved or loaded. However, it is by definition in the scope of a session. Hibernate will detect any changes made to an object in persistent state and synchronize the state with the database when the unit of work completes. Detached state. A detached instance is an object that has been persistent, but its session has been closed. The reference to the object is still valid, of course, and the detached instance might even be modified in this state. A detached instance can be reattached to a new session at a later point in time, making it persistent again. This feature enables a programming model for long-running units of work that require user think time. Core interfaces and classes. Session Factory Interface. A session factory is an expensive to create thread-safe object intended to be shared by all application threads. It is created once, usually on application startup, from a configuration instance. Session interface. A session is an inexpensive non-thread safe object that should be used once and then discarded for a single request, a conversation, or a single unit of work. Configuration class. It represents an entire set of mappings of an application's Java types to an SQL database. It also allows you to specify configuration properties. Transaction interface. This will perform operations like commit, begin, and more. This is a must when performing operations like saving, deleting, or updating an object. This works above JTA. Query and criteria interface. This will allow you to execute the HQL or SQL queries. Also, the query interface allows you to set the HQL parameters as well. The criteria interface is also very similar with the query interface, but with some nice add-ons to create queries. Session Factory. You have one for each database, and it maintains a thread-safe cache of compiled mappings. It also might hold an optional cache of data. Session. A session will not obtain a JDBC connection or a data source unless it is needed. It will not consume any resources until used. In order to reduce log contention in the database, a database transaction has to be as short as possible. Long database transactions will prevent your application from scaling to a highly concurrent load. Configuration. This will load the .dot properties or XML configuration files. This is the object which tells Hibernate how to get the connections. This is used to build an immutable session factory. The mappings are compiled from the various XML mapping files. How to configure Hibernate. This could be achieved using an XML file, a properties file, or both. The file hibernate.cfg.xml is the main configuration file in which all the database connections are defined, and also the mapping files. Also, you can define a hibernate.properties file to override some properties as well. This will be discussed later. Hibernate mapping. Hibernate uses runtime reflection to determine persistent properties of classes. These mapping documents are used to generate a database schema and provide persistence. On the picture, you can see the mapping documents, which are loaded by a configuration object. Then, a session factory and session are created in order to make the objects persistent. Here's a hibernate.cfg.xml example file. This is based on the year model proposed in part 2. At the beginning of the file, there's the DTD version, which defines the elements allowed on the XML file. Then, all the data source properties are defined: the driver class for the JDBC connection, the URL for the connection, the username and password, and the dialect. The dialect allows Hibernate to generate SQL optimized for a particular relational database. Then, on line 10, it is defined the connection pool we're going to use for the examples. In this case, we are using C3P0, which is a very useful library for connection pools. After this, the pool properties are defined like the minimum size, maximum size, and timeout. Then, on line 18, if we want to show the SQL statements, which is a nice thing when developing. On line 19, the query substitutions, which will change every true value by 1 and every false value by 0. Then, a catch implementation is defined, which will be reviewed later. At last, on line 22, the first mapping file we're gonna have on our project. Here we have the first section of the file. Review the additional comments. Here we have the database connection section of the file. Review the additional comments. Here we have the dialect definition and which are available. Here we have the pool definition. Review the comments. Remember to download the jar file from the URL proposed here. Here we have the additional properties and the cache provider. Review the additional comments for each line. Remember to download the jar file proposed here. Here we have the mapping definition list as previously explained. Review the additional comments. Exercise. Create the Hibernate configuration file. This is a class diagram to identify what we have to map. This is the same model used on part 2, but this time we're using a class diagram. We have the person class, the teacher and student classes, which inherit from the person class, the course class, and the student course class. This is the ER model of the previous class diagram. With these two diagrams, you'll be able to map all the entities. Let's take a look. This is the mapping file for the person entity. The name of the file is person.hbm.xml. As you can see, all the properties of the class are defined and also some rules. At the beginning, once again, the DDD version, which in this case is the Hibernate mapping 3. Then, the package in which the file will be placed. After this, on line 6, it begins the class definition and the mapping. On line 6 is defined the mapping between the class and the table. In this case, the table and class name are the same, but this is not a must. Of course, the class name should follow the Java coding standards convention. Then, the ID definition or primary key of the class. At the class level is an attribute named ID and integer. The column associated is called person ID. Inside this ID element, there is the generator strategy for this column, and as you saw in part 2, we were using identity, and that's why we defined that strategy on the file. After this, it comes all the attributes of the class, like name and last name, with their attributes like the Java type, string for both, and the maximum character length allowed, which is 50. Also, those attributes should not be null. Before getting into the creation of the file and further comments, you have to install a very useful plugin for Eclipse Helios, which is the Hibernate plugin from JBoss. Review the next video to check how to install the plugin. This is the first part of the person HPM XML file. Review the additional comments. This is the class definition of the mapping file. Review the additional comments. As it was explained before, here's the ID generator strategy. Let's see the ID generators available. Identity. Supports identity columns in DB2, MySQL, MS SQL Server, Sybase, and a hypersonic SQL. The return identifier is of type long, short, or end. Assigned. Lets the application assign an identifier to the object before save is called. This is the default strategy if no generator element is specified. Sequence. Uses a sequence in DB2, PostgreSQL, Oracle, SAPDB, McCoy, or at a generator in interface. The return identifier is of type long, short, or end. High-low. Uses a high-low algorithm to efficiently generate identifiers of type long, short, or end, given a table and column. By default, hibernate unit key, and next high, respectively, as a source of high values. The high-low algorithm generates identifiers that are unique only for a particular database. Native selects identity, sequence, or high-low depending upon the capabilities of the underlying database. Foreign uses the identifier of another associated object. It is usually used in conjunction with a one-to-one primary key association. Select retrieves a primary key assigned by a database trigger by selecting the row by some unique key and retrieving the primary key value. This is the properties or attributes definition of the class. Review the additional comments. Domain classes. These are classes in an application that implement the entities of the business domain, meaning that are the classes that define the business and are important concepts on the application. So far, we have the mapping files, but we need the Java classes. With the Hibernate plugin you have installed, these Java classes will be created automatically, performing a few configurations on Eclipse. Take a look at the next video. Please continue with the exercise. Take a look at the next video. First, we're going to create a new package. Come tutorial db. Once the package is being created, we're going to create a new file. This is the HBM XML person file. On this document, we're going to define the mapping between the person class and the person table on the database. First, we're going to define the package. Come tutorial db. Then we're going to define the class attributes, like the name, and of course, the name of the table. Then we're going to define the ID of the class. The name will be ID, and the column that belongs to the person table. In this case, person ID. Also, the data type of the ID. Next, the generator strategy, identity. Right now, we're going to define all the properties of the class, like the name, which is a string, and the column associated. We're defining the length, 50 characters, and we're setting the not null attribute. Now, the rest of the properties. For example, the last name property. Also, string, and the column associated on the table. The length, and the not null attribute. Here's the mapping of the person class. Now we're going to generate the person.java using the Hibernate code generation. Session factory, session, and transaction. The purpose here is to use the session factory, session, and transaction interfaces to see if our mapping and Hibernate configuration files are working. First, download the Hibernate classes from the URL proposed. Once you have downloaded the zip file, put out your lib folder, the jar file described here. Remember to include those files also on your project class path. This is how the Java build path of your project should look like. Remember to use the Add Jar button. Let's see the code proposed here. This is a class with a main method to test if the files that we have so far are working. First, we have to use a configuration object and instantiate the class. Then, when instantiating the object, the configure method is being called. This method will load the Hibernate CFG XML file, and it will also check the mapping files. After this, we need to create a session factory object using the build session factory method. On line 15, we must open a new database session from the pool, and we can now open a transaction. Because we want to save an object on the database, we must open a transaction. After this, we create a new person object. We set all the attributes, and then the save or update method is being called using the session object. If this passes, then we must commit the transaction in order to make persistent the changes. At the end, we close the session. Here you have a summary of the classes being used on the previous code. Please review. Here you have a summary of the first part of the code. Please review. Here you have an explanation of the save or update method. Please review. Notice that we're using the save or update method because Hibernate is going to manipulate the ID of the object, and through that attribute, Hibernate can decide if the save method must be called or instead the update method must be called. Please continue with the exercise. Take a look at the next video. Now, we're going to create a new class. The new class will be Hibernate main. We're going to check the public static void main method to be able to run the class. First, we have to define a configuration object. Of course, you have to use the one on org hibernate cfg package. Once the object is being instantiated, we're going to call the configure method. Also, we're going to define a session factory. We're going to use the configuration object to build a session factory. Once we have the session factory, we're going to define a session object. Using the session factory object, we're going to open a new session with a database. Now we're going to create a transaction. We're going to use the session object to begin a transaction. Now we're going to create a new person object. This is a new persistent object. We're going to set every attribute on the person object, like the name and the last name. Once we have set all the attributes, we're going to call the save or update method of the session object, and we're going to pass a person object as a parameter. After this, we're going to commit the transaction, and we're going to close the session objects. Now let's run the class to see if we save a new person object on the database. Here's the SQL used by Hibernate to insert a new person object on the person table. Let's take a look at MySQL. As you can see, there's a new object been saved. Let's take a look at the following example. In this case, we want to test if we can load an object from the database. The beginning of the code is the same. The configuration, session factory, and session objects are the same as before. After opening the session, we try to load an object using the get method. The method takes two parameters. One is the class of the object we want to load, and the second is the primary key value of the object we want to load. If the object is null, then It's because there is no object with that ID on this case. If exists, we're printing the name and last name. Notice that for this example, we did not open any transaction because it's not needed. Here are some additional considerations about the example. Please review. Please continue with this exercise. On this example, we're trying to perform a different task over an object on the database, which is to update the info previously shown. As you can see, it's almost the same as before when loading the object from the database, but this time we added new lines. If the object was found, then a transaction is been opened and we change some info of the object's attributes, and then we call the update method on the session object. We could also call the save or update method. After this, the transaction is committed. Please review these additional comments about the previous example. Please continue with this exercise. On this example, we want to delete an object from the database. This is achieved using almost the same code as before, because the first thing is to load the object from the database. If the object is found, then we open a transaction and the delete method is called using the session object. After this, the transaction is committed and the session object closed. Review these additional comments about the example. Continue with this exercise. Here you have a summary about the methods being used and what the SQL statements are. For example, if you use the save method, then an insert will be performed on the database. If you use the update, then an update will be performed on the database. One of the most used is the save or update because Hibernate can decide which method should be called, save or update. Life cycle. As you saw before, the configuration object is created, then a session factory is built and a database session is been opened. After this, it depends on what you're going to do with the object. If you want to load an object or list of objects, no transaction is needed. Only the get the object using the primary key or use an HQL to load several objects. After this, close the session and the session factory. If a transaction was used, then it should be committed or rollbacked based on previous errors. Until now, we have mapped an entity with no relationships, but as you saw on the model, the other entities have relationships. On the next slides, we'll be reviewing those relationships and how to map those on the HBM XML files. Mapping relationships. One-to-one association. For this matter, we're going to use the teacher entity. This class has a relationship with the person entity, but as a specialization of the person class. This also means that the teacher entity inherits from the person class. On this kind of relationships, the two entities shares the primary key value. That's why the primary key of the teacher entity is also a foreign key. So to be able to map this kind of relationship, we must use the foreign key generator strategy for the ID element. Notice that the ID definition is almost the same, but with the difference on the generator strategy. Notice that inside the foreign generator, we're defining a property, which is called person. Take a look at the end of the mapping file, the one-to-one relationship. The name of the project is person, so that's why. On the relationship, we're establishing the name of the object, the class name, and additional properties. The constraint property specifies that a foreign key constraint on the primary key of the map table references the table of the associated class. The cascade option is set to all because we want all operations being cascaded on the person entity. Also notice that the years of service attribute is being defined here. Take a look at these additional considerations about the mapping file. Review these comments about the relationship's properties. Take a look at this example. It's almost the same example when saving a person, but this time we have to not only create the teacher object, but the person object as well. Also, we have to set the relation between the two objects, and this is achieved on line 22, where we set the person attribute of the teacher object. Also notice that only the method saveOrUpdate is being called over the teacher object. Because we have defined the cascade option, the person object will be saved as well. Review the additional comments about the previous example. Please continue with the exercise. Take a look at the next video. On this exercise, we're going to create a new mapping file. Teacher HPM XML file. We define the header of the file. Now, we're going to define all the mapping properties. The package, com_tutorial_db. Now, class definition. The name of the class and the table associated. Now we're going to define the ID property, the name, and the column of the table. In this case, the generator strategy is going to be foreign. Because we're using foreign, we're going to define a new parameter, name property, and the value is person. This will be defined later on this file. Now we're going to define the rest of the attributes that the teacher class is going to have. For example, years of service. And of course, the column definition. Now we're going to define the relationship between the teacher class and the person class. We're using a one-to-one relationship. The name of the object will be person, and the class will become tutorial_db person. We're adding also new attributes like the constraint, which is going to be set on true, and the cascade option, which is going to have all. Now we're going to add on the Hibernate CFG XML file the new mapping file. We copy the mapping resource and we change the name to teacher. Now we're going to run the Hibernate code generation again. This will create the person and the teacher Java. Now let's create a new class. This is going to the teacher save class. Remember to check the public static void main method. Once again, we're going to define the configuration object. And we're going to call the configure method. Now the session factory object. And through the configure object, we're going to build a new session factory. After this, we're going to create a new session object. Using the session factory object, we're going to open a new session. Now, let's create a new transaction. Using the session object, we're going to open a new transaction. Now we're going to create all the objects. First, the teacher object. Because the teacher object has a relationship with the person object, we need to create a person object as well. Now we have to set all the attributes on the person object and also on the teacher object. For example, the name and last name of the person object. Now we're going to set on the teacher object the person object. This is going to establish the relationship between the two objects. At the end, we just have to call the saver by method, passing the teacher object as a parameter. Notice that we don't have to save the person object. Due to the relationship, it is going to be saved as well. We close the session and the session factory. Now we just have to check on MySQL if the both objects were created. Let's run the application. Here you can see the both SQL. There's a person, and we're going to select all the files from the teacher table. The person ID is 7, also the teacher ID. Many-to-one association. This is one of the most used associations because when you apply the normalization forms on a database tables, the result is tables related with foreign keys. These foreign keys are not primary keys. Take a look at the course entity mapping file. As before, we are mapping the ID and the attributes of the entity. At the end, there is the relationship between the course and the teacher entity. This is a many-to-one relationship. As before, we have to define the name of the object, in this case, teacher. Then, the class name and the column which identifies the foreign key. As before, we have a cascade option as well. In this case, we're not going to apply any cascade option because we're establishing that to create a course, the teacher must exist. Notice that this is not a defined rule and it depends on the business logic of the application. Review these additional comments about the many-to-one association and the course mapping. Take a look at the example proposed. The purpose here is to create a new course. As we have said, the teacher must exist on the database, and that's why we're loading the teacher first. Once the teacher is loaded, a new course is created, and as you can see, the teacher is associated with the course object, setting the teacher on the course object. Once again, a transaction is being used. Continue with this exercise. One-to-many association. This kind of relationship is not always mapped because the decision relies on the business logic of the application. Sometimes it's useful to map this kind of relationship, but other times it does not have any sense at all. Notice that this association will add a collection to the object in which it will be manipulated persistent objects. Also, when using this kind of association, it should be used as a bidirectional association. On one side the many-to-one, and on the other side the one-to-many. In order to give an example of this association, let's pretend that when you create a teacher, you will be creating the courses at the same time. So, the teacher HBM XML file should be changed. Let's take a look. Here's the teacher HBM XML mapping file. It's the same as before, but at the end we have the one-to-many association. First, we have to define which list type we will be using for this type of relationship. In this case, we're using a set. Then, we have to define the name of the collection, which is courses, and the associated table. Then, the inverse element, which defines if this side of the association is the end of the relationship. Next is the cascade option, and for this example, we're using the all delete orphan, which means that all the operations will be cascaded, and if any object is left orphan, meaning that the object is not on the collection, it will be deleted. The last option of this element is the lazy. This is a very useful property and it helps with the performance of the application. This will tell Hibernate to load the collection only if the collection is referenced by any code. Inside the set declaration, there's the key element which defines the column on the table which defines the relation. At last, the one-to-many association. This defines only the related entity class. Review these additional comments about the association. Take a look at these considerations about the cascade and lazy options. Take a look at this example. The purpose is as previously defined. Save a new teacher with its courses. At the beginning, once again, is the same, and a transaction must be opened. Then, the teacher is instantiated and all the attributes been set. Before creating the courses, you must call the saveOrUpdate method of the session object on the teacher object. This will allow you to establish the relation with its courses. Then, every course is created and you set on every course the teacher object, and on the courses collection of the teacher entity, the new course is being added. At the end, the transaction is committed and the session closed. Once the objects are on the courses collection, Hibernate will save every course on the database. Review the additional comments about the previous example. Continue with the exercise proposed. Many-to-many association. This kind of relationship is denoted by a very special case. This is used when two entities have a many-to-many relationship, but no extra attributes are defined within the relation. For example, the relation between a product and its categories. One product could belong to several categories, and one category could have many products associated. On the model proposed, the relation between a student and a course is almost like this if the score attribute was not included. Let's assume that for this part of the tutorial, the score attribute does not exist. Let's see how the course mapping file will look like. As you can see, the mapping is like the one we have at the beginning. The only thing new is the association at the end of the file. For this matter, we're using the course entity as the owner entity of the students enrolled. Once again, we have to define which kind of Java collection use. For this example, we will be using set. The name of the collection will be students. The inverse element is set to false because this is not the inverse side of the relationship. Then the table associated, and as you can see, is the third table or the relation table student course. Then the cascade option, which is set to save update, which means that both operations will be cascaded. Once again, the lazy element in true. Inside the set element, the key column is defined. At the end, the many-to-many association, which defines the class, which is a student, and the table column associated. Here you have additional considerations about the relation. Please review. Here's the example about the association. In this code, we want to create a new course and enroll two students as well. The teacher is loaded from the database and the course is instantiated. The relation between the course and the teacher is set, and once again, before including the students into the collection, we have to save or update the course. After this, two students are being loaded and included into the students collection. Once the students are included, the transaction is committed and the session closed. Review the additional comments about the code. Continue with the exercise. Composite ID. The model we're working right now has a relationship between the student and the course table, but with an extra attribute, which is the score of the student on the course. This will lead us to map the entity and, of course, create the HBM XML file and create a Java class. Let's take a look at how this mapping file will look like. As you can see on the picture, this student course table has a primary key composed by two fields that also are foreign keys. Also, there's a score attribute on the table definition. Because the primary key is composed by two fields, the ID element of the mapping file must be defined differently because we have no generator strategy and the primary key is composed. Here's the mapping file of the student course entity. Let's start with the ID definition. In this case, we have to use the composite ID element to define the primary key. The key properties are all the fields that compose the primary key, and in this case there are two fields, course ID and student ID. Notice that we have named the primary key as student course ID and the type is a class. This is because we're thinking in objects, so this primary key must be defined on a class with two attributes. The class name is student course ID. At the end of the mapping file, there are the two foreign keys defined as well. one for the student relation and the other for the course relation. Please review the additional comments about the student course mapping file. Here's the course HPM XML file updated with the new definition of the student course entity. Notice that the one-to-many association changed in several ways. The name of the collection is still students, but the reference table is now student course, and all the operations are going to be cascaded. Now the class on the one-to-many association is the student course. Please review these additional considerations. Here, there is an example of saving a course with some students and their scores. At the beginning is the same as before. Then, the teacher that will be assigned to the course is being loaded. Then, the course is instantiated and all the attributes being set, and the save or update method is being called with the session object. Then, a student is being loaded and the new student course ID class is created. You have to set every attribute on this object, which are the course ID and the student ID. Then, an object of the student course class is created. The primary key is being assigned, which is the student course ID object. Then, the score and the course and student relationships. At line 36, the student course object is being added to the student's collection of the course object. At the end, the transaction is committed and the session closed. Review these additional comments about the previous example. Continue with the following exercise. Annotations in Hibernate. This is a different way to map entities on a Java application using Hibernate. This implementation uses JPA or Java Persistent API, and also the Java annotations introduced on version 5. Hibernate will make persistent the entity defined with annotations. Before getting into the annotation definition, download these two files and include those files in your class path and lib folder. Annotations are defined using the @ symbol before reserved words. The entity annotation defines a class as a persistent entity which will be persisted by Hibernate. Also, there's a table annotation which defines the name of the associated table. The ID and generated value annotations define the primary key and the generator strategy to be used. The column annotation allows you to define each attribute with its related column on the table. You can define elements like name, length, nullable, and unique. As you can see, using XML files or annotations is very similar. Let's take a look at an example. Here's the example of the person entity, but using annotations. The class is defined as an entity, and the name of the table is also defined. Then, each attribute is being defined with its characteristics, like the ID and generator strategy, the name column, and the last name column. For example, on the name and last name columns, the not null annotation is being used. Every attribute has its own get and set method. Remember to use the annotations from the Javax persistent package. If you use annotations, the database and entities classes are defined on a different file. This is the persistent XML file. Here's the file defined with the elements. At the beginning, the version of the persistent schema. Then, the name of the persistent unit, which is tutorial ADV. Then, the entities list, and then all the database connection properties. This file must be placed under the source folder within a folder named meta-inf. Take a look at the example of saving a person and object. The first thing is to load the persistent unit definition, and this is achieved using the create entity manager factory of the persistent class. Then the entity manager factory creates an entity manager which allows you to get a transaction object. Then you begin a transaction and the person object is created and persisted using the entity manager. After this, the transaction is committed and the rest of the objects closed. Continue with the proposed exercise. Take a look at the next video. On this exercise, we're going to create a new Java class. It will be person AN. We're going to use annotations for this exercise. First, we have to define all the attributes that this person AN persistent entity is going to have. For example, the ID, the name, and the last name. Using Eclipse, we're going to define the setter and getter methods. Just select all and click OK. Once we have defined the getter and setters, let's define the persistent characteristics. Using the add entity, our person AN class is defined as an entity. Now the add table to define the table associated with this entity. Now let's define each attribute. For example, the add ID. Also, we're going to define the generator strategy. In this case, we're going to use identity. This is very similar like using the XML file. Now, we're going to define the add not null on the name attribute. Also, the column associated on the person table. The same thing we're going to define with the last name attribute. The add not null and the add column definition. Also here we can define the length attribute. Now we're going to create a new folder, the meta-inf folder. This is the folder in which we have to define a new XML file. Let's create the file. The file is the persistent.xml. There's the header of the file. Now we're going to define each property of this persistent XML file. We define the persistent unit name, tutorial ADV. Now we're going to define the classes ComTutorialDB person AN. Now the rest of the properties: the connection, the URL, the username, and the password. Also, the Hibernate dialect. If you want, you can take all these parameters from the Hibernate CFG XML file. These are all the properties. Now let's create a new class to test what we have done. It's going to be the person AN main class. Remember to check the public static void main method. In this case, we're going to use the Entity Manager Factory. Using the Create Entity Manager Factory method. Take a look at the name, which was defined on the persistent XML file. Now we're going to use an Entity Manager. Using the Entity Manager Factory, we create an Entity Manager. Now let's create an entity transaction. Using the getTransaction method from the Entity Manager. Now we begin a transaction, and we're going to create a new person AN object. We have to set all the attributes of the person AN object. Now using the persist method, passing the person AN object as the parameter. Now we're going to commit the transaction. We close the Entity Manager and the Entity Manager Factory. Let's run the file and see if a new record is being created on the person table. Now let's see on MySQL if the new record was created. There's Laura Kent. HQL, or Hibernate Query Language. Hibernate uses a powerful query language, HQL, that is similar in appearance to SQL. Compared with SQL, however, HQL is fully object-oriented and understands notions like inheritance, polymorphism, and association. HQL has several aggregate functions like sum, average, and more. Also, you can use expressions like group by, order by, and subqueries. With the exception of names of Java classes or properties, queries are case insensitive. Take a look at the example proposed. We're getting all the objects from the course entity. In order to execute the query, we have to use the query interface and the session class. The session class has a method called createQuery, which receives the HQL to be executed. Once the query is created, it can be called several methods. For example, the list method. Take a look at the example. This shows how to list all the courses that the database has. The beginning is the same. We instantiate a configuration object, then the session factory and the session. Then, at line 19, the query is created, and after that we get the courses list. Continue with the following exercise. Where clause. As it was shown on part 2, using HQL allows you to use many SQL classes, like the where keyword. The roles are basically the same, but with some differences. Remember, HQL is object-oriented. Using HQL, you can pass parameters as well, and you can also use the like keyword with the wildcards, joins, and more. Take a look at the example. The code is like the previous one shown, but it was added the where clause. The first thing is that after the name of the class, we add the object on the HQL. Notice that the class name has the first letter capitalized and the object is lowercase. This is needed on the where clause because we have to use the object to reference any attribute of the class. On the where clause, we're filtering by the ID attribute of the course class, and a parameter is being passed to the HQL. The name is ID course. Although you could use the where condition as in SQL, the one proposed here is the best way to do it. After the query is being created, the parameter value is set. Notice that the setInteger method is being used because the ID attribute of the class is integer, so the comparison should be made with an integer. Review the summary of the previous code. Take a look at the next example. This shows how to use the like keyword with the where clause. In this case, we're using the name attribute of the course object. Because the attribute is a string, then we must use the setString method to the set parameter value. Notice that also on the setString call we're using wildcards. Take a look at the following example. So far, we have used the attributes of the object, but we could also use those attributes that have a relationship with a different entity. For example, on the course entity, we have the teacher, which relates with the teacher entity. So for example, if we want to list all the courses in which the teacher has more than 3 years of experience, the HQL is like the one proposed here. So far, the HQL used before get the whole object. We could also return one or more specific attributes of an object. This is achieved using the select part of the HQL. As you can see on the example, we're selecting the name attribute of the course object to be returned by the query. Then, on line 20, notice that the list did not return course objects. Instead, it's returning only a string with the course name. This example is like the one proposed before, but now it's been shown how to retrieve 2 or more attributes on a HQL. You just have to add all the attributes you want to get from the object, and this time the query will return per each row an object array. Every element of the array will denote one attribute of the object. One of the very helpful things you can do with HQL is that you can actually instantiate a new object inside an HQL statement. You just have to create a new class in order to use it on the HQL. For this matter, let's define the following tutorial bin class. This is a simple class with two attributes, and notice that the class has a constructor that receives two parameters. It's important that the attributes should have the getSub methods. Let's see how we can use this on an HQL. As you can see on line 18, the HQL is being constructed, and we're using the new keyword to instantiate an object of the tutorial bin class. We're calling the constructor who takes two parameters, name of the course and name of the teacher. As we have said, this is very important because if you don't have on the class the proper constructor, it will not create the object. The rest of the HQL is the same as before. Then, on line 23, we have a list with tutorial bin objects inside. This example is the same as before. The only difference is that we're getting only the first result on the list. This is achieved using first the setMaxResult method of the query object at line 21. Then, at line 22, we're using the uniqueResult method of the object query. This will get only one result from the list. Continue with the exercise. Criteria, interface, and restrictions class. Hibernate features an intuitive extensible criteria query API. The interface criteria represents a query against a particular persistent class. You have ready-to-use methods like add order, and more. This will facilitate the construction of an SQL. Take a look at the example. This is the same example as shown before when introducing the like keyword, but in this case we're using the criteria interface. On line 19, we're creating the criteria object using the createCriteria method of the session object. Notice that we have to mention the class from which the criteria will be constructed. Then, a new restriction is being defined on line 20. Notice that we're using the like method of the restrictions class who takes two parameters, the name of the attribute to be used for a comparison and the value. Then a list is being returned. In this example, we're using again one of the examples previously shown. In this case, we want to check against the years of service attribute of the teacher attribute on the course entity. This could not be used as it was with the HQL. We must define an alias for the attribute which is an object. As you can see on line 21, the alias is being created. The first parameter is the name of the attribute on the course entity, and the other is the alias. Then, on line 22, we're adding the restriction using the alias and the GE method, greater or equal. Also, on line 23, we're sorting the results using the name attribute and the ASC ascending method of the other class. Criteria and pagination. Also with Hibernate you can perform pagination, which is a very common task on many applications. The criteria class has two methods, setFirstResult and setMaxResults. The advantage is that the Hibernate will translate this limit query into the native SQL of the RDBMS. This is an example of returning a limited list. In this case, we're listing only the first 4 courses that exist on the database. On line 21, we're defining from which row we should start. The first one is 0. Then, we define that only 4 courses should be loaded. Continue with the following exercise. Native SQL queries. You can also express queries in the native SQL dialog of your database. This is useful if you want to utilize database-specific features such as query hints or the connect keyword in Oracle. It also provides a clean migration path from a direct SQL JDBC-based application to Hibernate. Hibernate 3 allows you to specify handwritten SQL, including store procedures for all create, update, delete, and load operations. Take a look at the following example. As you can see, we're using the create SQL query method and the parameter is a standard SQL. Also, the return list has at each position an array of objects. On this kind of queries, you can use the SQL standard. Also, if you want to take advantage of the object-oriented programming, you can return a list of objects using native SQL queries. As you can see on this example, on line 20, we're adding the entity to the SQL. This will return a list of course objects. Continue with the following exercise. Named queries. Named queries are those SQL queries that you write on a mapping document and it's identified by a name. You can also add parameters as well. Take a look at the SQL name query example. On the course HBM XML file, we have added a new name query at the end of the mapping declaration. A parameter is being passed to the SQL. This code shows how to load a name query. On line 18, the name query is being loaded using the name. Then we set the parameter on the SQL, and then the list is returned by the list method of the query object. Please continue with the exercise. Take a look at the next video. Let's open the course HBM XML file. Under the class attribute, we're going to define a new property. This is the SQL query property. We define the name, courses filtered, and we define the return property. We define the alias, and then the name of the entity, in this case CompTutorialDB course. Now let's define the query we're going to execute using this name query. We define a parameter name course pattern. Now let's create a new Java class to test this name query. The name of the class, name query. Check the public static void main method. You can copy the first 3 lines from one of the examples previously made. Remember to select the right imports for every class or interface. In this case, we're going to define a new query, and we're going to use the session object to get the name query. This is the courses filtered query. Now, using the query object, we set the parameter using the setString method, course pattern, and the value. Now we just have to define a new list. This is going to be the list of courses that matches the parameter being defined. Now we're defining new for loop to see all the courses. At the end, we close the session. Now let's run the file to see how many courses we have. Joins. As well on SQL, we have joins. On HQL, we also have joins. There are many joins available, but the most used are inner, left outer, and right outer. Notice that you must use aliases if you're planning to use it on the HQL. For this matter, let's take the course class in which we have a collection of students. The exercise is to load all the courses in which the birth date of the student is greater than a certain date. Take a look at the example. The initialization part and query creation is the same as we have seen so far. The difference is on the HQL. Take a look that we are using the distinct clause on the HQL. Also, an inner join is being used to actually get every object of the student's collection defined by course.students. The name of the object is the student course. On the where clause, we compare against the birth date of the student course object. Review the summary of the previous code. Continue with the exercise. Caching. On the development of enterprise applications, caching is often used for optimization. A cache is designed to reduce traffic between your application and the database by conserving data already loaded from the database. Of course, this could add additional tasks for you, like from time to time invalidate or empty the cache. Types of caching. First level cache. This is the session cache. The session cache caches object within the current session. Hibernate uses this cache by default. Second level cache. This is an optional cache, and first level cache will always be consulted before any attempt is made to locate an object in the second level cache. Query level cache. Hibernate also implements a cache for query result sets that integrates closely with the second level cache. First level cache. The first level cache is the session cache and is a mandatory cache through which all requests must pass. The session object keeps an object under its own power before committing to the database. If you issue multiple updates to an object, Hibernate tries to delay doing the update as long as possible to reduce the number of update SQL statements issued. If you close the session, all the objects being cached are lost and either persisted or updated in the database. Second level cache. The second level cache can be configured on a per class and per collection basis, and mainly responsible for caching objects across sessions. Any third-party cache can be used with Hibernate. An org Hibernate cache provider interface is provided, which must be implemented to provide Hibernate with a handle to the cache implementation. Query level cache. This is an optional feature and requires 2 additional physical cache regions that hold the cache query results and the timestamps when a table was last updated. This is only useful for queries that run frequently with the same parameters. Caching implementations. cache or Easy Hibernate cache, OS cache or OpenSymfony cache, Swarm cache, and JBoss tree cache. cache or Easy Hibernate cache is an open source standards-based cache used to boost performance, offload the database, and simplify scalability. It can scale from in-process with 1 or more nodes through to a mixed in-process, out-of-process configuration with terabyte-size cache. For applications needed a coherent distributed cache, cache uses the open-source Terracotta server array. OS cache is a Java framework developed by OpenSymfony that makes it easy to cache content in web applications. It's also a caching solution that includes a JSP tag library and set of classes to perform fine-grained dynamic caching of JSP content, servlet responses, or arbitrary objects. It also provides both in-memory and persistent on-disk caches. Swarm cache is a simple but effective distributed cache. It uses IP multicast to efficiently communicate with any number of hosts on a lane. It is specifically designed for use by clustered, database-driven web applications. Such applications typically have many more read operations than write operations, which allows Swarm cache to deliver the greatest performance gains. Wrappers have been written that allow Swarm cache to be used with the Hibernate and JPOX persistent engines. JBoss cache's goal is to provide enterprise-grade clustering solutions to Java-based frameworks, application servers, or custom-designed Java SE applications. Since JBoss cache is a replicated cache, state is always kept in sync with other servers in the cluster. This makes any state stored in JBoss cache resilient to server crashes or restarts, achieving a high availability. JBoss cache still is, as its name suggests, a cache. It is a product designed to cache frequently accessed Java objects in order to dramatically improve the performance of applications. Caching strategies: read-only, read-write, non-strict read, write and transactional. Read-only: if your application needs to read but not modified instances of a persistent class, a read-only cache can be used. This is the simplest and optimal performing strategy. It is even safe for use in a cluster. Read-write: if the application needs to update data, a read-write cache may be appropriate. This cache strategy should never be used if serializable transaction isolation level is required. Cache configuration: for the cache example on this tutorial, we will be using the cache implementation. For this matter, we have to include a new file inside the source folder. This is the ehcache.xml file, in which only a default cache is being used. This is just a basic configuration of the file. This is a test class to see the performance of the cache implementation. Almost all the code is the same as we have seen so far, but line 18 is new. Here, we're defining that the query must be cached. The test that the code is being performing is pretty simple. We're getting the same person's list twice, using a cache implementation and making the query cacheable. The second list should be obtained from the cache. Run the file and you'll see the HQL being shown only once. This is the HQL you'll be seeing. Now delete the line 18 and run the file again. You'll be seeing the HQL twice.